G'day guys. Alright, well this is kind of weird, but let's do it anyway. I think this could actually work quite well. Alright, so this is the first video that I'm making for you guys. Now I'm not going to do this for every set of notes, only when it's necessary. So sometimes you might get consecutive lessons where I've made videos, depends what we're studying. Sometimes I might just provide the notes on their own if I don't think a video is necessary, or sometimes I might provide the notes and some links to some videos that someone else has made on YouTube or something like that. So a combination of the three, all right? But whatever you're required to do for a lesson, it will be outlined on the online schedule in Google Classroom. All right, well, let's get straight into it. So for this lesson, we're looking at problems in 3D, specifically problems that use compass bearings and angles of elevation and depression in the same question. Now, this is quite tricky, but it's one of those things where if you know how to do one problem, you kind of know how to do them all. There's just a bit of a trick to it. I think everyone's probably pretty comfortable with problems that just involve angles of elevation and depression, and people are pretty comfortable with problems that just involve compass bearings, but putting those two together is where it gets a little tricky. So pay attention to this one example, and if you get this one example, you should be able to do all subsequent questions without too much trouble. All right, so let's have a look at this question. So from the top of a cliff 160 meters high, two buoys are observed, okay? Two floating ball thingies in the ocean. Their bearings are 337 degrees and 308 degrees. Their respective angles of depression are 3 degrees and 5 degrees. Calculate the distance between the buoys. All right, so the trick here is in picturing what the question is actually talking about, forming a sort of three-dimensional image in your head. Now, I find the best way to tackle these problems is to split what's being described in the problem into two diagrams, a side view and a top view, okay? Let's start with the easiest aspect, which is the side view. So we're going to ignore the bearings part of the question and just deal with the part of the question that talks about angles of depression, okay? So I've got two buoys. I'm going to call them B1 and B2, buoy 1 and buoy 2. Their angles of depression from the top of a cliff, right here, are 5 degrees and 3 degrees. Okay, so we can very easily come up with this diagram. And that's from the side. So that's done and dusted, okay, that's easy. Now, here's the thing. Normally, when we use these angles of elevation and depression diagrams to, calculate horizontal and vertical distances and angles and so forth, usually we would assume that those points along the horizontal are lined up with one another, that Y, B1 and B2 are points along the same line. But that can't be the case in this question because B1 and B2 have different bearings. So what we need to do is imagine that we're a bird in the sky looking directly down at the cliff, okay? So we're going to switch over to the top view diagram now. This point here is the very top of the cliff. In other words, it's a bird's eye view looking down on this point, okay? And you can see from the bird's eye view that Y, which is that point in the middle here, Y, B1, the first buoy, and B2, the second buoy, are not lined up in the same direction. That's because B1 and B2 have different bearings. The bearing of the first buoy is this here, which is 337 degrees. And the bearing of the second buoy is this here, 308 degrees. So what we want to do is simplify things a little bit, okay? So if we go down to this diagram underneath, what I've done is I've gotten rid of the compass, basically, all right, and I have evaluated this angle in here, which is simply 337 degrees minus 308 degrees. It's the difference between the two bearings. And that gives us the included angle between the lines B2Y and B1Y. So we have an included angle between those two lines. Okay, so what actually are we being asked to calculate here? Well, let's look back at the question. Calculate the distance between the buoys. In other words, what is B1, B2? So do we have enough information to calculate that? Well, if we use both of these diagrams wisely, then yes, actually we do. We've already determined the included angle between B1Y and B2Y, that's here. Angle B1Y, B2, that's 29 degrees. We've already been through that. Now, if we think about it, if we can do some trigonometry now, going back to the side view diagram, if we can do some trigonometry and determine the length of B2Y and the length of B1Y, then we can add those two measurements to this diagram, and then we'll have everything we need. We will have an included angle, we will have these two side lengths here, which means that using the cosine rule, we will be able to find this side. All right. So returning to our side view diagram, what we're going to do is use our Z rule from geometry, which says that if this angle here is 5 degrees, then this angle here must also be 5 degrees. And if this is 3 degrees, then this must be 3 degrees. And now we're only just a couple of steps away from finding B1Y, this line here, and B2Y, this line here, which are the same as these two lines here, B1Y and B2Y. If we can find them on the side view, then we can add them to this top view diagram here, okay? So, looking at our side view, we have the opposite side of those two right angled triangles. That's the height of the cliff, 160 meters, and the adjacent sides of both of those respective triangles are B1Y and B2Y. So, if we just scroll down, taking the tangent of the 5 degree angle, we get 160 over B2Y, that's just opposite over adjacent. Rearranging that for B2Y, we get 160 over tan of 5, which is round about 2 kilometers, 1,828.8 odd meters. All right, and now doing the exact same thing for the 3 degree angle. If we take the tangent of that 3 degree angle, we get opposite over adjacent, which is 160 meters over the side length B1Y. Rearrange that for B1Y, and we get 160 over the tangent of 3 degrees, which is just a little bit over 3,000 meters, okay? All right, so we're in business. We've now found B1Y and B2Y, these two side lengths here. And when you have those two side lengths and you have the included angle between them, you have everything you need to then go ahead, use the cosine rule to find the other side. And that's what I've done here. Looks a little bit complicated, but rather than use a square root sign, I've just done brackets and a power half, okay? So B2, B1 is this, so it's getting a little bit messy, this diagram, but B2, B1 is going to be equal to the square root of this side squared plus this side squared minus 2 times this side times the cosine of the angle between them. All right, which is exactly what I've done here, and you get 1,702.55 meters, which is the distance between the two buoys, i.e. the side length B1, B2. All right, hopefully that made sense, guys. Make sure you just send me an email or something if you need some extra help when you're doing the problems, and good luck. Bye.